Welcome to another episode of Terry's Notes, and today we're going to be looking at another type of transformation, which is a reflection. So let's begin. So suppose we have a triangle A, B, and C, right? And we want to perform a reflection on this triangle, right? Now on the graph here we have, this is the x-axis, and let me tell you from now, if that is the x-axis, it is also the line y is equal to 0, right? Some people do not grasp that concept, but the x-axis is the line y equal to 0. So if they ask you what is the equation of the x-axis, it's y equals 0. The vertical axis is the y-axis, right? And the y-axis is also the line x is equal to 0. Now, a long time ago when I now started doing this, what I used to remember is that if it's the x-axis, then it's reversed. It's the line y equals 0. If it's the y-axis, then it's reversed. It's the line x equal to 0. Okay? So what we're going to do, we're going to perform a reflection on this triangle. So whenever you have to do a reflection, you need to indicate what the mirror line is, right? So we are going to use the y-axis as our mirror line, right? Or the line x equals 0. So therefore we're going to perform a reflection. So it's a reflection in the y-axis or the line x equal to 0, right? Now this is what we use to describe a reflection, right? You have to give the mirror line. So if the y-axis is the mirror line, now this is the point A here. We look at the distance of A from the mirror line. So we see that from here to here we have 2 units. So we have to go 2 units behind the mirror. So therefore this point here will be A prime, which is the image of A. Then in the case of B, we draw a line from the point B to the mirror line. We have 2 units. So therefore we go 2 units behind the mirror line. So therefore this is B prime. In the case of C, we have 1, 2, 3, 4, 5. So we have to count 5 units behind the mirror line. So we go 1, 2, 3, 4, 5. And this is C prime, the image of C. So therefore our triangle now is, so this is our image, right? Now if you notice something, the triangle, this is the object, right? And this is the image. If you notice something, the triangles have the same size, the same shape. However, they are mirror images of each other, right? But the 2 triangles are said to be congruent, right? This is a term that you're going to meet a lot when you're doing transformational geometry. So the 2 triangles are said to be congruent. Their angles are the same. Their lengths are the same because the length AB is the same as the length A prime B prime. The length BC is the same as B prime C prime. So the triangles are congruent, right? This is something that they ask you and they expect that you say that the object and the image are congruent, right? What else do you need to know here? Okay, so alright, so this is the solution basically. So we are doing a reflection in the line x equal to 0 or my y-axis, right? So this is my object and this is my image. Okay, now let's do another one. In this case, I am going to do, we have a triangle again, and let's label our axes. So this is our x-axis or the line y equals to 0. This is our y-axis or the line x is equal to 0. So we want to do our reflection here. So let's, hold on, I don't have enough space here. So let me use the final answer. So this was our object, which is the triangle. This is our image. This is the line. This is your x-axis, or the line y equal to 0, right? So if you notice, the point, let's say B, is 2 units from your mirror line, and the point B prime is 2 units behind the mirror line. The same thing for C, right? You have 2 units here. We have 2 units here. In the case of A, you have 1, 2, 3, 4, 5. So we go 1, 2, 3, 4, 5 units behind the mirror line, and that's how we get A. All right. Now they can give you a diagram like this, and they can ask you, what is the transformation? Now, to identify a reflection, the object and the image will have the same size, the lengths will be the same. What will be different is that the image looks flipped. So they are mirror images of each other. So if this was on a piece of paper, and I were to fold the paper along the x-axis, the two images, the object and the image, will coincide, meaning that the point A will line up to A prime, B will line up with B prime, and C will line up with C prime, right? That is if I fold it along the x-axis or the line y equal to 0. Now, in a question, they will ask you to identify the transformation. You might have to describe it. If it's a reflection, you need to state what the mirror line is. The mirror line in this case is y equal to 0. And you could be asked to construct a line to show where the mirror line is. All you need to do, if you know it's a reflection, let's say you draw a straight line between, let's say A and B and B prime, sorry. And what you do, you use your compass and you draw some construction lines. So you start at, let's say, the point B, and you draw something like, you draw an arc here, and using that same arc, you're going to draw another arc here, and then we draw this line here, which is our mirror line. So really and truly, the mirror line will be the perpendicular bisector of BB prime. So the line B prime, if we find the perpendicular bisector, will be the mirror line. Right? So a perpendicular bisector is just a line that divides a line segment into two equal parts, right? So the line segment here is B prime. So the perpendicular bisector BB prime is really my mirror line. Okay? So let's do another one here. We have, let's label our axes. We have the x-axis. We have the y-axis. So the x-axis is the line y equal to 0, and the y-axis is the line x equal to 0. And I've drawn a line here, which is y is equal to x. And I'm going to perform a reflection of this triangle here, which is C, D, and E. And I have to show what happens. Now, the angle is the mirror line, so this is our mirror line, right? And some students get confused here now because they're not sure what to do, right? What you have to do is to draw a line. Let's say you want to find the coordinates of C prime. You have to draw a perpendicular line. This is a perpendicular line here. That's 90 degrees to your mirror line, and then extend it. So this distance here, right, has to be the same as this distance here. So therefore, this point will be C prime. In the case of D, you have to do the same thing again. You draw a line that is perpendicular to the mirror line. Then you have to measure this distance here. That is this distance here. Measure this distance. And we go that same distance behind the mirror line. right? Now I'm just sketching here, so this could be slightly, I have the solution in the next slide, right? And you do the same thing for E. So the solution really will look like this, right? So this is our line y equal to x, which is our mirror line, and this is our object, and this is our image, right? So CC prime, you know this line here is 90 degrees, and the same thing for D as well. Okay, so reflections are pretty straightforward. Let's do one last one. Okay, so we have a triangle A, B, and C. This is our x-axis, and I'm going to say it again. It's also the line y is equal to 0. This is our y-axis, and it's also the line x equal to 0. This line that we have here, this vertical line here, right? It's the line x equal to 7, right? Why is it the line x equal to 7? This is our x-axis here, right? This is our x-axis, and we are counting 0, 1, 2, 3, 4, straight up to 7. So therefore this is the line x equal to 7. If I were to draw a horizontal line at this point here, the equation of that line is y is equal to 5. Okay, so be careful how you label your lines. So I want to do a reflection in the line x equal to 7. So x equal to 7 is our mirror line. So this is our mirror. And let's start with B. We draw a line from B to the mirror line, which is 90 degrees. We measure this distance here. So this is 1, 2 units. So this will be 1, 2 units. So therefore this point here is the point B prime. To get C, I draw a line, a perpendicular line to the mirror line, and I measure my distance. So 1, 2. We go behind the mirror line. 1, 2. So this here is C prime. We do the same thing for E. So we draw our line going this way, and then we measure the distance, which is 1, 2, 3, 4. So I'm going to do the same thing behind the mirror line. So 1, 2, 3, 4. So therefore this point here is A prime. So this is our triangle. So this is our image, and a question I see that they like to ask is, what is the relationship, or what is the geometrical relationship between the two images? The object and the image, they are congruent, right? So remember that word, congruent, right? The object and the image, they have the same shape, the same size, the lengths are the same. What is different is that they are flipped, right? They are mirror images of each other. If you fold, if this was on a sheet of paper and you fold along the line x equal to 7, B and B prime will line up, C and C prime will line up, and A and A prime will line up. Okay, so this is the final solution here. So this is our object, and this is our image, right? And this is our line x equal to 7. Alright, so I will do some more past papers on this particular topic, because I know sometimes it can be challenging. And like I've said previously, you need to practice before you become good at maths. Okay, take care.